Hey everybody, Adam with FANUC. We're going to talk today about remote tool center point and CAD-to-path, how those work together, how to set them up quick and easy using FANUC Roboguide. So this is going to require a little basic understanding of Roboguide. Hopefully you already know how to add some fixtures, add some parts. If you don't, please go watch my first tutorial for just the Roboguide basic tutorial. But otherwise, let's just jump right into this thing. As you can see, I've already put in a fixture called table. I've also added another fixture that I'm calling tooltip. This is going to be my point of interest for the day. This could be, in this case, it's actually like an applicator. So it'd be like if I wanted to lay a bead of silicone or adhesive on a part. But I mean, this could be a deburring tip, a grinding wheel, air spindle, anything like that. So I'm just calling it tooltip. Real quickly, if you need to know how to add a fixture, simply right click, add fixture, and these are your two best options. Single CAD file, when you click that, you'll get a pop-up window that takes you to your Windows browser, and you can find any CAD file that you have drawn or your team has drawn. Roboguide prefers IGES format, so save yourself some time, save your file as an IGES. Otherwise, we do have the FANUC built-in CAD library that has all kinds of fun things that you can put into your cell that are already built in to make your cell look like something fun. All right, so you've added a fixture that's probably got your work cell and your deburring device or your applicator device. The next thing that's important is to add a part to your work cell. Same story, right click, add part. You can use what's built into the FANUC library, or you can bring in your own IGES file. For this example, I brought in something that I'm just calling test block. I brought in just this little square, this little rectangular part, some rounded edges, just something that has a real basic geometry to help us for this for the sake of the tutorial. But I brought in the test block, and again, please watch my tutorial on how to get it onto your part. But once you have your robot tooling set up, which again, CAD file either from your browser or from FANUC's library, just make sure you go into parts, activate the test block. You can edit the part offset to make sure the block is on your tool. That's not the meat and potatoes of this video. We'll just assume that you've already accomplished that and have that running. So I'm going to bail out of there. All right, so here we go. The first important thing that we need to do is we need to set up a remote tool center point, which is just a user frame out in space of where you want the part to touch. I guess for this example, you know, I've got this opening that's an applicator, but what I'm going to do is maybe I'll pretend it's a deburr device, and I'm going to treat this corner edge as the point of interest. So here's what we'll do. I'm going to say I want a user frame. I'll just call it the tool tip frame. Apply. I want to edit that. Roboguide makes it really easy because it actually shows you a plane, and it shows you the point of origin. So you'd have your orient origin here, your X direction along this side, your Y direction along this side. Since we're using Roboguide to make all the paths, why not do it the easy way? Otherwise, you'd have to jog your robot over here, teach your 0, 0, teach your X, teach your Y, and it'd be done. That's how you can do it in real life on your physical robot. But for me, I'm going to do the quick and easy way, which is using the technology to my advantage. So I'm going to go ahead and put my orient origin right on the leading edge of this, or as close as I can for now. You can see how good I am with mouse clicks here. But I'm going to put this right about there. Yeah, that looks good. So that's telling the robot that, hey, this is the point of contact that I want to make. We'll end up marrying the edges of the part to that. So if I was doing an application of silicone or adhesive, I'd probably put it more toward the middle and that. But for now, we're going to pretend it's deburring. So I'm going to put it here. Say apply. And now you can see that I've got this nice little orient origin, XYZ, marked right there. That's going to become our remote tool center point. Right now it's a user frame, but it's going to become an RTCP. I'd like to take a quick moment just to let you know that you do need an option for this to work. So let me pull this up. On this robot, the only options that I've added to my virtual robot is I've added the motion package, option R809, and I've also added remote TCP, remote tool center point option, J624. Those two are going to be needed to get the job done here. So make sure you purchase this for your real robot, your physical robot, or you're not getting anywhere. So just that little plug. All right. So the next thing I want to do, let's start with the easy stuff. I want to define a home position, a starting place for this robot. Now, on this part, if I only wanted to deburr, 2 or 3 sides, I wouldn't really be too concerned about my J6 orientation. But in this case, I want to go around the whole part, which is 360 degrees. Now, LR mates, they have the ability to rotate positive 360 and minus 360 for a total of 720. But if I come up to this part and I start at 0 and try to go 360, I'll actually hit an axis limit. So what I want to do is I want to start this part at either positive 90 or negative 90 rotation of J6. That way when I'm doing my work, for example, if I start at positive 90, I'll actually end the workpiece at negative 270. So that way I don't run into axis limits. So let's go ahead and define a home position real quick. The robot's already in a great spot. I'll call it home. If I look at my current position in world, you can see that I already have J6 at 92 degrees, which is great. If I didn't, pretty easy, just, hey, I'm in joint mode here. I can bring this so, the 0, position of this robot would have the part facing forward. I don't want that. I want it closer to 90 or more. So let's go ahead and put this into something nice. Perfect. You know what? Close enough. So let me go back into here, shift record. All right, so now I have a home position taught that has biased, it has unwound J6 90 degrees. Perfect. Next step, we need to tell Roboguide how to use, we're going to use CAD-to-path, and we need to tell it what edges of this part I want to touch this, and at what angles and rotations, etc., etc. So I'm going to make my life easier real quick, and I'm going to take this robot, I'm going to rotate him up. I'm doing that because I want to teach this outside edge, and I don't want to be trying to look up from the table. I just want to be able to see it. So perfect. Now I can see it. Now I know that the robot will wind. I'm going to call it counterclockwise is negative. So being that the robot's starting at positive 90, I want my path to go around the part this way so that as the robot deburrs, it'll actually unwind. If that doesn't make a ton of sense, don't worry. It's hard to wrap your head around what's positive, what's negative. You can always change it later. That's why we test it in Roboguide. If it fails, you just flip it and change the direction. So we need to go down to this parts section, it might start out looking like this. Parts, block, I got my test block. But if you expand this out one more, there's this item called features. Okay, I'm going to right click and I want to draw a feature. I get this nice little pop-up. If your pop-up doesn't look like this, sometimes it looks more like this. Just make sure you turn on the view and edit panels just to make it look good. So there are so many ways to draw features on your part. We can do it with a surface to where, if I wanted to draw a pattern or shape on a surface, we can do freehands, loops, but I'm gonna go easy. I'm gonna do an edge line because what'll happen is Roboguide will snap my mouse to these edges. So you can see as I move my mouse along, Roboguide is selecting, it's highlighting these edges for me, and you can also see that it's highlighting a normal vector. Okay, what do I mean by normal vector? You see the yellow and the white lines saying, hey, I'm snapped to this edge, but I'm pointing down. Or I can move up here and I can say, all right, I'm still snapped to that edge, but I'm pointing outwards. It all depends on what normal vector you want, what side you're trying to deburr. Is your flash on the bottom? Is your flash on the side? How you're doing this. So for this example, I'm going to go ahead and keep all my normals facing outward, and I'm going to go around the part like this. So here's what I want to do. I want to pick a starting location. I'm just going to arbitrarily kind of pick this flat surface. As soon as I click, now Roboguide is following my mouse, following these normal vectors, and defining where to go along this path. Now, you do not need to click all along this edge. That is a misconception. You don't need it. What I do care about is defining the normals everywhere that there can be a drastic feature change. So I'm just going to move my mouse over to here, and I'm going to click. All right, so I clicked once at the beginning, I clicked once over here. You can see the normal vectors on the screen showing, the path it's going to take. Now I'm just going to rotate my part around, and I'm just going to bring my mouse over here. You can see it's fanning out, it's following the normal, coming around the edge. You can see how it kind of snaps and does something funny. This is no bueno, no good right here. So let's bring it here. Click. Perfect. You can see it's starting to outline this path. Let's move on. Click. So anywhere there's a feature change that could throw off the orientation of the robot. This is easy because it's a box with a couple fillets, but click. And then go over here. But you can imagine that if you had a more complex part geometry, that there'd be a few more clicks required and a few more opportunities to mess up the robot. Click. And go up here. Paying attention to my normal vectors. Click. And we'll sweep around this corner. Click. And then the last thing I want to do is get back to my starting position, which is, you can see the little deviations here. I'll get back to my starting position. When I get here, I want to double click. There we go, double click. So now as I back out, there's my work. The robot has highlighted this outer edge with the normal vectors facing outwards. You can actually even see the little arrows showing the direction of travel that the robot's going to work on. And we now have a feature taught. Congratulations. So now what do we do? Well, as soon as we have a feature taught, we get this new pop-up. You see this just showed up. Feature 1 from test block. Well, let me name it. Okay, I'm going to name this thing block edge. Okay, so that's nice. It's going to ask me, hey, what do you want your Teach Pendant program to be named? Because the whole point of CAD-to-path is I'm clicking along, but I want Roboguide to make the program for me. I never want to pick up the Teach Pendant. So my Teach Pendant name, I'll just call it deburring. Okay. So this nice little box, this one little thing on your screen right here is going to end up making a program for me. So scrolling down, you basically just got to answer some questions. Yes, my user tool is the vacuum. I set that up a while ago. Nice magic little box here. Do you want to use RCTP? Yup, I do. And what frame do I want to use? I want to use that user frame 1 that we taught, that tooltip frame. That's the one out here at the end of the tool. Now we have a bunch of tabs up here that just help us really dial in the program. And this is where you can spend a lot of time really polishing this. But I'm going to walk you through it and go through some of the important things real quick. So first, the program settings. Going to be pretty intuitive here. Just read through. It's how do you want to get to the first point? Well, I want to go linear, and I do not want to go that fast. I want to go linear at 500 millimeters per second. Perfect. So that means from my home position, how do I get to the first point? There it is. How fast do you want to go along these segments? How fast do you want to go? Well, I have my options for different units. I can even make this indirect addressed, and I can use, say, register 1 or register 2, 3, 4, 5, 6, and have a variable. I'm just going to go in here and just hard code it at 100 millimeters per second. How do you want the blending, the termination types? Well, continuous 100 is going to give you that smoothest look. That's by far the most smooth transition. It's the least irky-jerky, so I'm going to leave that. So look through and read through some of these things. If you want, you can call programs at the beginning or at the end of the feature. So if you have other programs, I don't, but if you had other programs, I can say, well, I want to call some status light, or call a vacuum, or call a, maybe you need to call the program that turns this spindle on and off, well, here's where you would put it. Okay. Next, position defaults. This one's a little bit more important. The first block is asking about these normal surfaces and, how you want it to track along. Do I want this thing to be in this orientation, in the vertical plane? Maybe my tooltip is 90 degrees out and I need it to be vertical or sideways or whatever. There are obviously 3 to the power of 3 ways that you can set this up, because it's what normal and what direction. I've already tested this, so this should work. But I want to be normal to my X plane and traveling along my positive Y. That's my tool frame axis relative to the features axis. So, if you look at the feature, you can see the XYZ here relative to that UT1 I set. So play with it. If you set it up and it doesn't work right, change it. The next thing is how you handle the orientation. See this little box change when I do this? It's, do you want to keep the part fixed, or do you want the part to rotate? So I can keep the part in one orientation and go around the RCTP, or I can keep the part still, and so instead of orbiting it, I can just tangent it. I'm going to keep it as this one. I want the tool to spin, so change tool spin. Next, you have 2 choices for how this thing's going to build a Teach Pendant program. The standard generation, which the robot will make the program with the least amount of points possible, or fixed distance. You can say, hey, every millimeter, I want you to teach a point, or whatever. Every tenth of a millimeter, teach a point. I like using this one because it builds a little more intelligence into it. But it also has some algorithms for, hey, what do you want me to consider a straight line? So if your part features were a little wavy, do you want it to consider the wave a wave, or do you want it to consider the wave a line? So you can kind of slide this bar and say, you know, how loose or strict do you want things to be considered a line? I'm going to leave it up here for now, it's fine. Same with circles. You know, here I've got these nice, perfect little arcs. So yeah, a circular move is going to be great in this case, but maybe yours is not a true constant radius. Well, if it's not, then just slide this bad boy down to never, and hey, don't use a circle. You know, follow my path the way I drew it. You know, so just play with these. These are the polishing and, you know, really making your program good. Apply these changes. You can set up an approach and retreat point. I'm going to leave mine blank because I have my own approach and retreat in the program, but this could build it for you. Position offsets. As you're running and playing, you can find that, well, you know, I don't really, you know, I need to reteach everything. I can just bump, you know, maybe across the Z, you know, get the part a little farther, you know, more engagement into the tooltip, or a little less, X, Y, Z. You can tilt the part, so you don't have to be at a perfect 0-degree normal. You know, the part could be on a 20 or 40 degree angle or something like that. All things considered when you're deburring. How you can blend those normals. These are some scalars and overrides that pertain to this. And then, for the most part, don't concern yourself with collision avoidance. There are ways that the robot can avoid a crash by going around features plus or minus a tolerance. In most cases, you'll never have to use that. So I'm going to come back here. I'm pretty happy with how everything looks, I believe. Roboguide doing a little autosave action on me. There we go. So I'm pretty happy with this program. So now what I'm going to do is I'm going to say, generate a feature Teach Pendant program. I'm just going to click this. There we go. That was it. We now have a program taught just by clicking that button, filling out this form and clicking that button. In fact, let me close this. You can see that it taught points and has segment speeds all along. Okay, let's take a look at what that program actually even looks like. Select. Here's a deburr block program that was SimPro auto-generated. We open it. Here it is. Sets up our user frame, user tool. There's my linear move, 500 millimeters per second to get to that first position. And then you can see that it's a line followed by a circle. All right, that's our first one. Then we got a line followed by a circle, followed by a line, you guessed it, followed by a circle, by a circle, and then the line that ends it. And you can see that it's got the RCTP function added onto all these segments, but it literally built this entire program for us. You can see all the segment speeds are at that 100 millimeter per second we told it to be, at a CNT 100 we told it to be. So we've got a program. That's great. The other thing I need to do is I have a main program that's just going to set the speed, start at my home position, end at my home position. So of course right here in the middle I need to call what we just built. So there's a main program right there. Start at home, go do your deburr, go back home. You can have that be whatever you need it to be. Now, before we hit the magic play button here, there is one more trick. No one teaches you, so hopefully you're still tuned in. Right click on your deburr block properties and turn off the singularity avoidance. Singularity avoidance does not jive with RCTP. Singularity avoidance is a great tool for robots. In fact, my robot's in singularity right now, or darn close to it. But you have to turn that off for RCTP. I'm also going to go to my main program and turn it off here as well, just because the main program is calling that. So I don't want singularity avoidance on for those. So make sure you do that. That being said, let's test this thing out. Cross our fingers it works. go. So that robot is tracing that line right across that tool center point, unwinds itself, goes back home. Let's zoom in on that and watch it again. Little close-up action. Pay attention to that point of contact. Run. And you can see how the edge of that part never leaves the RTCP, that 0, point of the frame. And that's all there is to it, my friends. It's actually really easy, and the more you use it, the easier it gets. You know, it's a very, very useful tool when your part has real complex geometries. You got a lot going on. Just set this up. Click, 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 click. Never had to touch the Teach Pendant. When you're done, you can take a backup of the robot, take a virtual backup in here, just the same way you normally would. File, file. Yep, UD1 is good. Backup. All of the above. Yes. It'll take a backup of all your programs, all your variables, all your settings, all your positions. There we go. That was easy. And then just access your tools and pop open this folder right here. That'll open up the folder that has all the backups in it. Toss them on a USB, put the USB in your physical robot, and then use the load function to load those files. And everything that you have just done in Roboguide will be on your physical robot. Questions or comments, let me know below. And as always, have fun coding.